Good afternoon and welcome to the ILIKA PLC post-AGM investor presentation. Throughout this recorded presentation, investors will be in listen-only mode. Questions are encouraged and could be submitted at any time via the Q&A tab situated in the right-hand corner of your screen. Just simply type in your questions and press send. The company may not be in a position to answer every question it receives during the meeting itself. However, the company will review all the questions submitted today and publish responses where it is appropriate to do so. Before we begin, I'd like to submit the following poll, and I'd now like to hand you over to CEO Graham Purdy. Good afternoon to you, sir.
Good afternoon, and many thanks for that kind introduction, and many thanks also to everyone who's taken the opportunity to dial into this presentation, which will be a quick update post our AGM. So we'll just go over the disclaimer. First of all, ILIKA at a glance. We are specialists in solid-state batteries at ILIKA. We've got two product lines. First of all, we've got our Stereax miniature cells, which have been designed primarily for IoT or Internet of Things applications, primarily actually for industrial applications, and then also for powering miniature medical devices. And secondly, we've got our Goliath large format cells, which are designed for the automotive sector and also for cordless consumer appliances. So our solid-state batteries for use in EVs are differentiated from a lot of other solid-state batteries because they use an oxide electrolyte in combination with a silicon anode. And this has a number of benefits, which we're going to go into in a bit more detail when we get to that part of the presentation. But it does reduce raw material costs and increase cell life. Company was founded in 2004, so we've been going for 19 years now, based in Southampton on the south coast of the UK. We have a very large patent family, patent portfolio. And we've made great progress, in particular with our Goliath battery development program that is addressing what will be the largest market for lithium-ion batteries, the automotive sector. And of course, we're well financed at the moment for that journey with a healthy cash balance at the end of April of this year. I've got Jason with me today. You probably caught sight of him sitting next to me when the camera was on earlier in the presentation. We've just had our AGM at which all of our NEDs as well as ourselves were present. You can see that we've got some rich expertise from industrially renowned organizations, starting with Rolls-Royce and Meggitt that Keith Jackson, our chairman, was active in. Of course, Monica's previous employer, Arm, has been in the news recently with their successful IPO on NASDAQ. And then Jeremy brings his substantial financial expertise to bear at the board. And I'll not go through the CVs for Jason and myself in this presentation. If you want to see a bit more information, you can do so on our website at your leisure. So the first point I'd like to make is that ILIKA has got an asset-light licensing model, and that differentiates us from a lot of other solid-state battery developers in that we're not intending to manufacture our Goliath batteries in particular in a gigafactory that we have built and operate. We feel that we are experts in the design and IP development for solid-state batteries, and our model is that actually we do a license and a technology transfer with partners who can take that know-how and implement it at scale, at low cost, reproducibly, and with a high degree of quality. So the deal that we've done with Cirtec, which I'll come back to shortly, is a good example of putting that business model into practice. And we're in discussions with a number of automotive partners who are joining us on the journey through to manufacturing readiness of the Goliath technology for a similar sort of industrial implementation. So let's start, first of all, with a few words on Stereax. So this is a unique miniature battery. You see some pictures of it there. First of all, top left, 3 M300 Stereax batteries pictured alongside some tablets, some current pharmaceuticals, just for scale. And on the bottom of the 4 images that you see on this slide, you can see the M300 powering some prototype devices that actually simulate what a neurostimulator might look like. So these would be implants. They would be connected to the peripheral nervous system. And instead of lighting an LED as they're doing there, they would send a small current through a nerve, which would be used to manage the particular condition that the implant is designed to address. So, advantages here are, first of all, you get reduced surgical intervention. You can see that the M300 is a very compact component offering high energy density. You get smaller device designs as a result, and therefore the impact on the patient is less. Safety, of course, is absolutely paramount in the medical sector. And because there can be no toxic fluid leakage from a solid-state battery, it's a big, unique selling point for that sector. And it's also got a high power density, so it can deliver the power pulses that are required for not only therapy, so delivering the pulse through the peripheral nervous system, but also for communication, because these devices often send data outside of the patient's body to be relayed, often by a mobile phone, into a database to help manage the condition that the patient is suffering from. Really interesting times, actually, in the miniature medical device industry. Sometimes it's referred to as the electroceutical revolution as opposed to the pharmaceutical industry. Here, really, it's being driven by innovation in the sector, not only for new therapies that require stimulation through nano amp currents, typically through the peripheral nervous system, but also actually to power sensors to measure some of the key parameters that help manage some of the conditions that we're indicating here. So neuromodulation is an exciting one. This is where we're stimulating nerves, usually in the lower back, to offset some of the pain signals that sufferers from lower back pain can find very debilitating. And this is an alternative to some of the very strong painkillers that have been prescribed, particularly in the US in recent years, often opioids that lead to societal addiction problems. If you can avoid that by using a tiny stimulator, then that's got not only benefits for the patient, but also benefits for society at large. One of the bigger markets also is implanted sensors for things like blood pressure monitoring, smart orthopedics for monitoring the physiotherapy regimes that patients go through after a knee or hip replacement, and therefore improve the outcome of that surgery. Smart surgical instruments for tracking surgical instrument movement and condition. And this is a very rapidly growing market as surgeons rely more on improved information during the surgical procedures that they're using their instruments for. Smart contact lenses, really this is not so much a medical device opportunity as related to the AR VR revolution, and trying to miniaturize some of the technology that is used to visualize imagery and therefore deliver AR solutions. And then finally, smart orthodontics, which is where you have a sensor that is placed on a what we'd call perhaps a brace in the UK, or an aligner, which is for straightening teeth, but also actually for sensing some of the chemicals that you get in saliva as an indicator of diseases that the wearer of the aligner may be wanting to track. So in terms of commercial demand for the Stereax product, we have very much a US-centric customer base. Over 3/4 of the demand for Stereax is coming from the US, with the remainder here in Europe. Biggest sector are implanted medicals, including some of the applications that we've just been talking about, but augmented by some of the, let's say, less regulated areas of smart dental implants and smart lenses, and then 1/4 of the pipeline related to industrial IoT. So covering orders from over 20 companies, sometimes with multiple orders, because they have multiple applications that they're looking to deploy this technology in. So since our last IMC update in July, when we had our full year results, we have been able to put in place a contract with Cirtec, which is our manufacturing partner in the US. So starting from just last month, we have initiated the tech transfer. I think it provides validation of the Stereax product and the process that we use for manufacturing it. We've got now a partnership with an organization that can deploy an economy of scale to manufacturing through their Lowell, Massachusetts facility, and an ability to ramp production as the demand from that customer base starts to increase. And also, actually, they have more business development resources that they can bring to bear to augment our commercial pipeline and bring more momentum to our commercialization efforts. So I think a very positive step forward now. We've had some great interactions with the Cirtec team already. We've started sending across some of the equipment that's needed to get them up and running as quickly as possible. We've been doing some training on the processes that we've qualified here in the UK. And we're having increased customer interactions, filling our pipeline going forward. So that's the update on Stereax. Let's change gear a little bit and talk about Goliath. So this is our solid-state EV technology. The whole automotive industry is going through a fantastic period of innovation and change. EVs and hybrids need high-performance batteries, and the benefit of solid-state is that we can offer further range through that combination of oxide electrolyte and a silicon anode architecture, and that's really through higher energy density versus lithium-ion batteries. So effectively, that means that the car can drive further with a similar weight and volume of battery pack, or conversely, you can reduce the size of the pack, get the same range, and that may be important for compact vehicles that you use in an urban environment. But perhaps one of the things that's most important is improved safety. So normal lithium-ion batteries are flammable because they've got that flammable liquid electrolyte in them. whereas solid-state electrolyte is typically non-flammable. That higher energy density can go as high as 500 watt-hours per kilo, although our roadmap will be getting there in stages. You get a reduced cell degradation, so you don't have the same risk of dendrite degradation that you've got in lithium-ion batteries. And perhaps what's becoming really important is this recyclability opportunity. So Goliath can be safely recycled. At the end of the battery pack life, you can remove it from a vehicle, take off the packaging, put it through a process, and there are no plastic separators, so polymer separators to have to remove. There's no toxic and flammable liquid electrolyte. Effectively, you can granulate what is a ceramic monolith and then extract the metals and put them back into the supply chain. And one additional differentiator relative to some other solid state offerings is that actually we've got a lower lithium content. You know, the price of lithium over the last couple of years has increased significantly. And so relative to a sulfide-based solid state battery, the ILIKA Goliath offering has got a lower lithium content and therefore lower raw materials costs. In terms of our target markets, we are going for high performance or high volume performance vehicles. And the reason for that is that actually in the first instance, this sector is willing to bear the what will be in the first instance slightly higher cost of manufacturing. They're not too price sensitive. Obviously, the mass market, in particular for compact vehicles, is more price sensitive because cost is a key driver there. But for performance vehicles, the owners are not too sensitive about that, and willing to embrace the values of a new technology without being too worried about whether it is the lowest cost solution that's on offer. This is a regulatory driven uptake or market change. The EU has indicated that the sale of new internal combustion engine vehicles will stop by 2035, and other governments around the world have made similar commitments. And this is a sector which contributes a large percentage of emissions. In fact, in the UK, it is the transportation is the biggest contributor to carbon dioxide emissions, and so this type of legislative change is really important for becoming a net zero economy. In terms of consumers buying EVs, the main reasons can be helped in many cases by a transition to solid state batteries. This range anxiety that we've talked about, of course, is alleviated by the use of solid state for longer range. Also, because solid state's a robust chemistry, it gives a longer overall battery life. And also the fact that it's a recyclable battery means that actually people's ESG concerns are addressed head on. So in terms of where we are with scaling up and demonstrating that this technology can be used and can be manufactured, we have a development manufacturing facility here in the UK on which we do our initial pilot manufacturing. In July 2021, so a couple of years ago now, we raised 25 million to extend our development program through to manufacturing readiness, what we call P2, and we're making strong progress towards that goal, supported by UK grants, including from the Advanced Propulsion Centre and the Faraday Battery Challenge. So our target is to produce 80 amp-hour cells with dimensions of 30 by 10 centimeters. And we are currently installing equipment to be able to upscale our printing, our coating capability, and also an automated assembly line. In terms of what you can look forward to going into next year and beyond, with Goliath, first of all, we tend to plot cell energy density. So we are now making progress towards our D4 data point. In fact, just today at our board meeting, we reviewed what we've called our D3 data point, which is where that red circle is. So very promising results there in passing that milestone. And the D4 data point, which we'll announce towards the end of this year, is a way of freezing the design for our first prototype, our P1 product, which we will manufacture in sufficient quantities for OEMs to be able to get comfortable with the progress that we're making on our roadmap here. By the end of the year, we'll also have hit lithium-ion equivalence in terms of energy density, between 250 and 300 watt-hours per kilo, which is pretty much state-of-the-art, which will be a good signal on our roadmap towards our minimum viable products, effectively an A sample, as shown on the bottom right chart here on this slide, which we will manufacture on our own pilot facilities, so those manufacturing facilities I was just talking about, with a view to then partnering with a manufacturing organization to go through to B samples and C samples. So, we will be collaborating at that point. B samples are of the format that I was just mentioning, so that 30 by 10 centimeter format at 80 amp hours. But that will be done at a manufacturing facility on equipment that is ready for industrial scale production. And then by the time you get to C samples, that is in larger quantities on the same production intent equipment, with a view to doing a tech transfer into a partner's gigafactory at that point. And in terms of the licensing opportunities and commercial collaboration, that really starts from pilot scale, so A samples onwards. Quick look at the competitive landscape. There's a lot of information out there in the public domain on different chemistry choices. There are some of our competitors who have taken a different route to the one that we have, and actually these different approaches have their pros and cons. So for instance, if you choose a sulfide electrolyte, you end up with a cell that has high ionic conductivity and therefore ease of transfer of the lithium ions from the cathode to the anode and back again. It's a malleable material which allows you to actually make strong interface connections. However, the downside is that it reacts easily with oxygen and moisture, can create some toxic gases as a side product, and therefore needs a lot of instrumentation and care in terms of the manufacturing facility, which in turn makes it an expensive choice. With the oxide electrolyte, it is stable in air. However, the downside is that it is more difficult to manage that interfacial resistance. So you need to develop a cell architecture which gives you the benefits that you're looking for. Lithium anode, so that's a lithium metal anode that has a very nice constant cell voltage with a high energy density, but given current lithium prices, it's very expensive, and the lithium can lead to dendrite formation, shortening the life of the battery. We've chosen to use a silicon anode approach, which we believe gives a longer cell life, less expensive than lithium, but it can lead to volumetric expansion problems, and therefore the choice of partner that we have for the lithium anode development is extremely important. And then finally, you can actually go for an anode-less approach. It's cheaper than the lithium anode approach because, of course, you don't have to invest in the lithium metal when you're making the battery. But we believe that there's a cell life compromise and volumetric expansion issues that you have to deal with when you go down that route. One of the ways that we engage with commercial partners from an early stage is actually to engage with them through grant-funded partnerships. We announced earlier this year our History project, which has BMW and WAE on the steering committee. So they give us advice on the end product results that they're looking for. It's a 24-month program, so it'll go through until the start of 2025. Total program value is £8 million. Actually, we get a grant of 2.8 million from that. It allows us to work with some of the best technology providers and UK universities and consulting companies. So we're working with Nexion, who are providing their state-of-the-art silicon anode material, and then CPI, which is the Centre for Process Innovation, who are doing some of the coating and mixing activities that are important to the program. And then with some of the UK's best minds and universities to help us make some important choices around cell architecture. So Imperial College in London, the University of St Andrews and UCL also here in London, and HSSMI, who are doing a full life cycle analysis. So HSSMI is an engineering consultancy that's doing this LCA of battery production and materials, so that we can share some of the information on the benefits of using our approach to solid state. So at this point, I'm going to hand over to Jason, who's going to talk you through some of the important work that we're doing on ESG.
Thank you, Graham. Good afternoon, all. So just touching briefly on environmental social governance, which is an important subject to us as a company, to you as shareholders, and to many of our potential suppliers and customers. We wanted to just highlight the work that we've been doing and our roadmap ahead, to just articulate where we're going from an ESG perspective. So from an environmental standpoint, we have completed our ISO 14001 certification. We have carbon footprint accreditation against Scope 1 and Scope 2. And continue to do product carbon footprint monitoring. And that activity will continue to evolve with our net carbon neutral plan. And we are starting to collate Scope 3 emission data over this current year. That's ahead of any regulatory requirements to do that. But we feel it's important, given the potential carbon footprint and the importance of this to the potential customers, for them to be monitoring, as they are more likely to be in regulatory regimes where they are required to do their Scope 3 emissions testing. So not only are we passionate about this ourselves as a company, but it fits nicely into our strategy to work with partners that ultimately have a same mindset. From a social point of view, we operate with known supply chain partners to ensure that we have full transparency in the sourcing of our minerals, as an example, to make sure that we have no conflict minerals from cobalt supply. We are pursuing equality, diversity, and completed an inclusion survey within our organisation over the last few months, and are developing a 5-year roadmap and opportunities framework to make sure that this stays front and centre in our mindset, and it's not just a one-off exercise, that it becomes part of our culture of the business as we move forward. From a governance point of view, health and safety always is at the forefront of every employee and director's mind, to make sure that we are operating a safe workplace, and that is reflected, as you can see, in terms of the number of incidents, reportables, lost time, etc. And we're continuing to ensure that we operate with the highest standards of governance we possibly can. Thank you, Graham. moving on.
Thank you, Jason. So just to wrap up the presentation part of today's interaction, so we can move on to some of the questions that have been submitted. In terms of what you can look forward to in the coming months, first of all, you will be seeing news relating to the activities that we are executing with Cirtec on the tech transfer and joint marketing, so the scaling of that part of the business. And then as we mature Goliath technology through defined milestones, we will be sharing information about them. We'll also continue actually to pursue grant support and commercial revenue through partnering to make sure that, in particular, actually the Goliath program is well funded through to manufacturing readiness. So the commercial opportunity continues to build for our technology across these very large addressable markets, some of the biggest markets on the planet. And we believe that that provides a strong platform for future growth.
Perfect, Graham. Jason, thank you very much for your presentation. Ladies and gentlemen, please do continue to submit your questions just by using the Q&A tab, which is situated on the top right-hand corner of your screen. But just while the company take a few moments to review those questions that have been submitted today, I'd like to remind you that recording of this presentation, along with a copy of the slides and the published Q&A, can be accessed via your investor dashboard. As you can see, I've received a number of questions throughout today's presentation. And if I could just hand over to you, Graham, just to read out those questions and give responses where it's appropriate to do so, I'll pick up from you at the end.
Very good, thank you. So we got some great questions that have been submitted. Many thanks for taking the time to share your thoughts with us. Let's just take it from the top. So the first one I've got here is, how can investors gain confidence that Goliath technology compares favorably with the many larger peers working on similar technologies? And can you share any performance metrics or benchmarking data? So first of all, in terms of confidence, I think actually, the collaborations that we have had and continue to have with automotive partners can give you confidence actually that experts in the field have interacted with us and continue to work with us on developing our roadmap. So, in particular, the history program, which started earlier this year, we've just completed the first 6 months of that. In order to be awarded that funding, we had to go through what was quite a stringent, technology review process, not only by the partners who had signed up, to spend their own money in many cases to interact with us, but also actually the screening body of the Faraday Battery Challenge, led by Tony Harper, who also mobilized independent experts to review our submission and some of the technical data that was part of that submission. So I think it's very much a vote of confidence in our approach and in our technology, and that's a very public flag of confidence in what we're doing. In terms of performance metrics, well, we've got a roadmap that I was talking about earlier on in this presentation, which gives some high-level information there, and as time goes on, there will be more data that we publish as we go through the roadmap progression of our product portfolio. Another question here about the Stereax business. It says, can you elaborate more on the exclusivity agreement with Cirtec Medical? Is this for all target markets, and how will this affect profit margins? So actually, there is information on the agreement that we have in place with Cirtec that was published in the summer, at the end of July, when we concluded that agreement. Actually, initially, Cirtec is our exclusive manufacturing partner. And the reason we did that was to ensure that we focus customer interactions with that one rollout of the technology, so as not to dilute our efforts. We're in the business of getting this technology to market as quickly as possible. And the fact that we're transferring equipment as part of this deal is a way of ensuring that Cirtec are in a position to be able to implement the Stereax offering as quickly and as competitively as they can. So in terms of profit margins, well, Cirtec will help us manage prices as effectively as possible, and we think that this was the right commercial decision in the context of other options that we had at the time. Next question: what major auto manufacturers have current agreements? So actually, the types of agreements that we have can fall into two categories. First of all, we've got the publicly announced relationships that we've got with organizations who are supporting our grant-funded collaborations. So in particular, I would point to the BMW Group and Williams Advanced Engineering, who are party to the collaboration agreement that structures the history program that we're currently working on. And then we've got a portfolio of about 6 OEMs who have signed up to early testing of our prototype batteries that we will be releasing to the market in the middle of next year. Now another question on the Stereax facility in Lowell, Massachusetts. So the question is, what is the current situation with the new Lowell, Massachusetts Stereax manufacturing facility? So this is actually an existing facility that has been operated for some time by Cirtec. They have a portfolio, a substantial portfolio of existing projects that they are executing there, and that's one of the principal reasons why we chose to actually work together with Cirtec, because they had an existing asset base that they could leverage in order to manufacture Stereax on our behalf. And the additional equipment that is being installed there is actually just the equipment that's needed in order to do some of the more proprietary and specific activities and unit operations associated with the Stereax production process. But they have a fantastic ISO accreditation, well known by the medical device industry already, with a lot of significant experience with working with customers in that sector. Next question is Goliath's expected performance still at 20 times cheaper, 1,000-mile range, 10-minute recharge? Well, I'm not quite sure where those claims have come from. It certainly won't be 20 times cheaper. In fact, most analysts who look at solid-state batteries expect that solid-state batteries will be at price parity with normal lithium-ion batteries, and in the first instance, actually probably slightly more expensive because of the economy of scale that lithium-ion batteries currently enjoy. So, lithium-ion batteries are made in gigafactories all over the world, principally in Asia, and the initial production capacity for solid-state will be at a smaller scale, and therefore actually the price point that can be achieved will be slightly higher, and that's relating to our strategy of making sure that the early adopters of our technology are performance vehicles and also volume luxury vehicles who are perhaps not so price sensitive. 1,000-mile range is more related to the size of the battery pack than the cell itself, but in due course there's no reason why that couldn't be achieved in larger vehicles. And the 10-minute recharge, well, actually it's expected that that is within the roadmap of the products that we're expecting to bring to market. There's a couple of financial questions here, so I'm going to let Jason pick one or two of those.
So, question here, what year do you now project that your common shareholders will begin to see Goliath income? We actually expect to see income, albeit very small income, starting from next year. So when, as Graham has already talked about, we commence sending out our P1 samples to customers for evaluation, those will be chargeable items, albeit at very low volumes. So Goliath revenue from product sales will commence in 2024, but we would expect that to grow, and perhaps the customer is alluding more towards the adoption at higher volumes, and that will relate to, as Graham showed earlier, that movement into the B and C sample timeline, when after evaluation from OEM partners, they would then look to pair us with someone within their existing supply chain who already manufactures traditional lithium-ion batteries, and we would work with them to produce batteries, our Goliath batteries, at a higher scale through the production process that they have in place, obviously adapted for solid-state batteries, to be able to cope with then the product proving process with the automotive sector. So we would expect that journey, as per the earlier slide, will take a couple of years for that to start to come through. So with revenue starting 2026, 27, starting to ramp up beyond just the sample level, and ever increasing after that through adoption as those vehicles then come to market onto the forecourts. Next question here, what is the short-term cash impact of the Cirtec deal? The very short-term impact is actually cash positive for the business. One of the items that we have highlighted earlier in the year at previous presentations is that the cost of very, very small-scale manufacturing within the UK is extremely high, and that was one of the reasons why we were looking to accelerate the licensing route with Cirtec, both because the volume and the economy of scale that they can bring to bear, having a much larger organization that can spread costs across multiple product lines, rather than our singular focus with the Stereax side of production, allows them to bring piece part cost down, but also because of their location in the US, with the Inflation Reduction Act, the IRA, that was enacted by the US government, put a cap on the cost of energy prices, and as all people in the UK would have experienced over the last year, the UK energy prices were extremely high, and that was felt very much through in our own cost base within the UK. So in the short term, the Cirtec deal is actually positive and improving our business cash flow. Then we would expect there to be a sort of a normalization of that as we move through the qualification process of the production at the Cirtec facilities, and then recommence shipment of product to customers, albeit now as a licensing deal rather than manufacturing at a smaller scale. That does reduce the direct income we take, but as I've earlier said, it also reduces our cost base as we go forward.
So the next question is, any idea why the US-EU Stereax split is 78-22%? And what growth rates do you expect from each? So the answer to that is primarily because most of the end customers for Stereax are actually located in the US. In terms of their headquarters, the big OEMs such as Abbott, Boston Scientific, Medtronic have all got a US operating base, and in the EU, actually the size of the medical device sector is significantly smaller. So I guess you might argue that the cost of healthcare is substantially higher in the US, but one of the benefits of that is that actually it is funding a substantial industry sector, and so that's why there is that skew towards the US. And actually, the growth rate in the US is actually higher than the growth rate expected for the medical device industry in the EU. So another question here: what percentage of the electroceutical medical market shown on the slide might be the potential revenue stream for ILIKA Stereax batteries? I think the best way to think about revenue from Stereax is to just do a bottom-up analysis rather than taking a percentage of the addressable market, because our bottom-up analysis is based on actual projects and actual customers that we know have an interest in the technology. And the guidance that we've given analysts over the years in terms of what the revenue that we could achieve from the Stereax business might be in the next few years is a ramp up to about £15 million on an annual basis, which will give us a decent return on the investment that's been made in the Stereax business. Jason, anything to add to that? No. Okay. So clearly, Cirtec will be instrumental in getting Stereax to market. Anything you can tell us about the commercial arrangement with Cirtec? So actually, the detail on that arrangement was announced in an RNS and a press release at the beginning of August. And we explained at that point that actually there will be a royalty bearing arrangement once the product gets through to market. So there's a competitive royalty rate that was benchmarked with the industry that we agreed with Cirtec. And before then, actually, when we're selling smaller quantities of batteries, there will be a profit sharing arrangement that will allow ILIKA to start recognizing revenue and profit from the sale of Stereax cells. Let me just have a look for the next question here that's relevant. Yeah, so there's an interesting technical question here on Goliath. Can you please provide more detail on the volumetric expansion characteristics of Goliath? So when any Goliath battery or any lithium-ion battery in general charges, what you do is you get a transfer of lithium from the cathode or the positive electrode, which is where the lithium naturally resides, through the electrolyte and into the anode. And in a normal lithium-ion battery, the anode has traditionally been primarily graphite, although in the future there is a trend towards increasing silicon content to give you a higher capacity for absorbing the lithium at the negative electrode. And in a Goliath battery, that mechanism is no different, really. There is a migration of the lithium ions from the positive to the negative electrode during charging. And this has the effect of increasing the volume of the anode and causes an expansion in the cell. And then when you draw a current from the battery, then the lithium moves back from that negative electrode from the anode back to the cathode, and that then reduces the volume of the anode. And because the cathode is a structured crystalline material, it tends not to expand and contract in the same way that the anode does. So you do get that breathing. And actually, the amount of volumetric expansion that you end up with is really driven by the choice of materials that you select for the anode. And you really want that volumetric expansion to be minimized. And so we are choosing anode materials which are aligned with minimization of that breathing mechanism, if you like, where the lithium ions go backwards and forwards across the cell. So next question here. How will Goliath compare overall against competitors in the targeted EV battery space, i.e. highly competitive, moderately competitive, etc.? And do you expect Goliath to become a global competitive leader? So yes, you know, the slide that we talked through earlier in today's presentation tries to give you some context as to the different choices that you've got in terms of different materials and different cell architectures. I would say that ILIKA has chosen a highly competitive battery technology in terms of safety, also in terms of the energy density that we can expect to achieve, and then thirdly, in terms of cost and ESG compliance. So the manufacturing cost of the Goliath materials and their combination into cell architecture is such that actually it is the most attractive of all solid state combinations because of the stability of the oxide materials relative to the sulfide materials, which are the alternative, and also the fact that oxide materials are straightforward to be able to granulate and then recondition and move back into the supply chain at the end of battery life. So, you know, we believe that we have a highly competitive technology choice here. Let's choose another one here. So there's a question here: would Stereax be able to improve the battery life in smart watches beyond the current life of around 1 day? And if so, is this something you're pursuing? So actually, Stereax is a technology that's really designed not to go any higher than about 5 milliamp hours in capacity, because above that you start to get battery designs and capacities that can be made more cheaply and more effectively. So the Stereax technology is a thin film technology that particularly suits itself to miniature batteries. Therefore, actually, I don't think that we will see Stereax in smartwatches. You know, your typical smartwatch battery capacity is, you know, 50 to 100 milliamp hours. So that is above the target market capacity for Stereax. So here's a question. CATL has been making great strides in the battery space. Would you like to compare or contrast Goliath specifically with them? So CATL is one of the largest manufacturers of batteries in the world. So based in China. You know, they have talked a lot about their blade technology in recent months and years. They've been reducing the amount of parasitic weight associated with the pouches that they manufacture. Clearly, they are a force to be reckoned with. We believe that Goliath is differentiated relative to the publicly available information on battery technology that CATL has made available. It's difficult to be categoric because, of course, if you're a big company, perhaps you have less incentive to publicize some of the work that you're doing and reveal the R&D programs that are core to value creation in your business. But we believe that we've got a sufficiently differentiated offering that we will find eager customers, even if they're already dealing with CATL.
If I pick up on actually and try and combine a couple of questions around cash and finances and bring them together in a single update. We haven't taken the opportunity in this presentation to reiterate the same financial numbers as we published on completion and signing of our finances in July. The numbers are freely available in the annual report, which you can find on our website should anyone want to go and look at those, or look back at the presentation that was made in July for a summary of those, which once again is available on our website. But to reassure everyone that despite us not reiterating those same numbers, that our cash position remains as expected. No new news, no, is good news. We continue on a steady footing and a safe position from a cash point of view. The next position that we would be making an update about our financial position would be at our half-year results in January when we publish that information, and we'll do a full update and presentation at that time. In terms of our cash burn and how that is impacted by the Cirtec, picking up on other questions related to that we've had through. So we would expect the cash burn to continue at the same level that we've seen over the last year. And the reason that stays at the same level despite the licensing contract with Cirtec is as we reduce the cost on the Stereax side of the business, and that is the main advantage that we would see in the short term, as I've already mentioned with the Cirtec contract, is Cirtec will bear the cost of some capital purchases and some investment themselves, as well as picking up the operational cost for a large proportion of the Stereax side of the business. So that really protects ILIKA and protects its cash burn on the Stereax operations. So the short-term licensing benefit is very much a cash protection. So as we reduce the cash cost on the Stereax side of the business, that then is replaced with those scale-up activities that we have talked about, that Graham's talked about, as we move through our implementation of our pilot line, addition of capital equipment, to make sure that we can deliver those A samples to our automotive partners so that they can do that evaluation and we can commence the commercialization route on the Goliath side of the business. So the result of those two elements, the reduction on the Stereax side, the increase on the Goliath side, is that we would expect for this financial year to really stand still from a cash burn perspective to what we have seen in the last year, which, as you will be able to see if you look back at our accounts, publications, still keeps us in a healthy cash position.
Thank you, Jason. So I can see that we are approaching the end of our 1 hour time slot for this session. So I'm going to answer one more question and then we'll wrap up. So here's a question. In terms of timescale, will Goliath be the first, second, third solid-state battery to mass market, and who's winning the race? So we have seen some early commercialization of solid-state batteries by some of the Chinese companies that we listed on our slide earlier on in this presentation. For instance, Qingdao and Welian are known to be early movers in the sector. I think it's important to understand that when people use the umbrella term solid-state batteries, not all of those batteries are the same. So actually there is a massive spectrum in terms of the approach that people take, and some of them are perhaps what a purist might say is a semi-solid-state battery that has a significant liquid content in it. I think the key thing is perhaps not who's going to be first, second, or third. So frankly, that is extremely difficult to predict, given that actually not all of this information is in the public domain. But actually, is the Goliath technology adequately differentiated? And we believe from our freedom to operate activity searches using our partnership with our patent search providers, and also our own competitive intelligence, that Goliath still has some significant USPs that differentiate it from the market and will continue to differentiate it from other offerings, and therefore will secure a significant segment, allowing us to generate a healthy return on the investment that we continue to make in developing the technology. Many thanks.
Graham, Jason, thank you very much for addressing all of those questions from investors. And of course, the company will review all the questions submitted today and will publish those responses on the Investor Meet Company platform. But just before redirecting investors to provide you with their feedback, which I know is particularly important to the company, Graham, could I just ask you for a few closing comments?
I'd just like to thank everybody who's taken the time to join this call. I hope if you've asked a question that Jason and I have done our best to answer it. And if there are any others that we haven't had time to cover, we'll take a look at them and post our responses after the call has finished. So many thanks again for your continued interest and support, and we look forward to giving you further positive updates in the coming period.
Graham, Jason, thank you once again for updating investors today. Could I please ask investors not to close the session, as you'll now be automatically redirected to provide your feedback in order that the management team can better understand your views and expectations. This will only take a few moments to complete, but I'm sure will be greatly valued by the company. On behalf of the management team of ILIKA PLC, we'd like to thank you for attending today's presentation, and good afternoon to you all.